Let's look at the remainder theorem and the factor theorem. First, the remainder theorem. Let f of x be a polynomial function. If f of x is divided by x minus c, then the remainder is f of c. So let's look at an example of this. If we take f of x equal to x cubed minus 4x minus 5, then let's find the remainder when f of x is divided by x plus 2. So with x plus 2, this is the same as x minus negative 2. So our c is negative 2. Let's find f of negative 2. So negative 2 cubed minus 4 times negative 2 squared minus 5. Let's see what that equals. It's negative 8 minus 16 minus 5, which is negative 29. So our remainder should be negative 29. Now let's check that by using synthetic division. So x cubed minus 4x squared minus 5. Let's put our coefficients. We've got 1x cubed, negative 4x squared, 0 x's, so I have to put that placeholder 0 in, and negative 5. And we're dividing by x plus 2, so c is negative 2. Okay, bring down the 1. Negative 2 times 1 is negative 2. Add negative 4 plus negative 2 is negative 6. Multiply negative 2 times negative 6 and get positive 12. 0 plus 12, bring down 12. Negative 2 times 12 is negative 24. Add negative 5 and negative 24, and that's negative 29. And remember, this last one to the right is our remainder. So we confirmed that our remainder is negative 29. Okay, the factor theorem. Let f of x again be a polynomial function. Then x minus c is a factor of f of x if and only if f of c equals 0. So if we have the polynomial function f of x equals 3x to the fourth minus 6x cubed minus 5x plus 10, let's first use the remainder theorem to find the remainder when f of x is divided by x minus 2. Okay, so here c is 2. F of 2 is equal to 3 to the 4th, 3 times 2 to the 4th, minus 6 times 2 cubed, minus 5 times 2 plus 10, which is 48 minus 10 plus 10, or 0. Then use the factor theorem to determine whether x minus 2 is a factor of f of x. Since f of 2 is 0, then x minus 2 is a factor of f of x. We showed that the remainder is 0, so it must be a factor.